Okay, sorry. In the last class, I have asked you a few questions. Have you gone through that? Are you able to hear me? Hello?
Yes, sir.
Yes. Okay. Why I ask one question that why
Sir,
even if in this kind of code, if you are able to see that if I displayed this A 100 times and it has to be show 100 plus 100, 200 times, but why in that case it was running only few times, the 20
sir,
times?
sir, we can place that p thread exit in the main also at the last.
That's okay. This p thread exit, but when you're making a p thread exit, this, which thread is going to be exit? Not this one. Because when the thread starts here and come to this place, it will not return back. Control does not return back. It is just saying here that to the parent, I have done. Since the control does not return back, if you write down p thread exit at the end, so that line itself is executed by the main process rather than by a thread. Because thread is not returning back once you call this a print hello through this thread create function. The thread's work is only to do this much. But when I'm executing this A and B previously for 100 times, then it has to be show you 100 plus 100 and one thread and another thread also 100 plus 100. Total is 400 times. But it was showing some 20 to 30 lines and then after it is going to be stopped. Was the reason. Have you identified? There is a very simple reason that what is the difference between thread and a process? Please participate.
It is having the same copy of the program and is running in the same main process.
Means no, both of them, all the threads belongs to a process are using the address space of the process. Yes or no? And every yes, since they are using the address space of the process, if you are running two threads and then after immediately suppose your parent process comes here or not. So how many process created? One thread created, another thread created, both the threads starts at a print hello. At the same time, your main process comes for printing this something. Then the main process may be completed quickly. Why? Because the main process needs only one lines, whereas your two threads wants to display 200 lines. If the CPU has to be make a context switching among these three things, which things? P1 process, T1 thread, and T2 thread, definitely after few seconds, this P1 process gets completed. If the P1 process gets completed, the process address space is going to be destroyed. If the process address space is going to be destroyed, how these two threads who are using the address space of the parent, how they will get the code? They cannot get the code. Are you getting my point? Because in case of normal processes, even if a child process created through fork, the child process have their independent address space. But in case of a thread, both the threads are using the address space of the parent. If the parent initially is dead, definitely child threads cannot get the address space of the parent. That's why they stop in the middle.
Sir, wait.
Yes, yes.
Sir, wait. We can.
Wait, very nice. Wait. So that's why what to do. So it will be completed quickly. Suppose if I'll make it here 20 or 100 or 50 this, and I'll just display this one 50 times. If I display this one 50 times, forget about this part, this one 50 times, then what happens? 50, 50, 100, 100, and this thread has to be 100, means 200 lines. It has to be displayed 200 lines, then it has to be done here, but it is not displayed 200 lines. If you can look into it carefully, just look into once, that is CD desktop, then that is GCC minus, GCC, what is the name? Thread 3.c, then minus LP thread, then dot slash a dot out, then if you can look into it, this is calling this, this is P thread 3, and it is doing like this SS. Just see. So what happens now? This display 0 and it is become terminated, and this two process not even executed. And once again you run the same thing. Once again you run. See here it is almost display 16, 15 kind of things, but it has to be display 50. Then what somebody told? Why don't this process wait for the thread to be completed? For waiting for the thread to be completed, like wait for the process to be completed, you are using a wait system call. Here there is a join system call. If you use a p thread join, then who will execute this two lines? If I write it here, main process, because your thread is executing these things, main process is executing these things. So after creation of the two threads, if I uncomment this, then what happens? Now my T1 and T2 is joined by the P. Joined by the P means unless until this T1 and T2 completed, the process cannot come to this place at all. Then what happens? First both the threads gets completed, then the main process is going to be completed. If I run now, you can exactly see both of them will be executed 50 times, then they're going to kill it. See, it is displayed up to 49. Why it is 49? Less than, I have given here less than this. Okay, I have given here less than 50 means up to 49 times. So this AB will be 49. Previously also there may be some 49 will be there. Yes, here there is a 49. Because there are two threads running this AB 49 and 49 times. That's why it is happening like this. Okay. So are you getting why it is happening like this? Because your main thread, if main process, if it is completed, then the thread who was created under that process will not get a chance to use the address space. That's why in the middle they completed. And last class I told, even if I make a P++, this P++ will not execute the actual result. Like P is 0, how many times this P++ will be executed? This P++ will be executed 50 times by T1 thread, another 50 times by T2 threads. But total should be what? 50 plus 50, 100. Now let's see, and I am displaying it here. Let's take how much it is coming here. So if you can go for this and execute this one. Yes. Now it is exactly 100. You can say that, sir, it is very nice. Both of them are executing this 100. Let's assume I'll remove this one, 5 to display more, and make it to 1000. Okay, 1000. So how what is the total value of a P should come at the end? Because P is a global variable, both process thread are using the same global variable, and two threads are executing this P 1000 times, means the total value should come 2000 times. Now look into it, it should come what? To 2000. Very nice. Then there is no need to explain one more. Let's you increase it to 1 lakh. Okay, the same thing. Coding has not changed. Only I'm changing, getting the values different. Now you see, now it is saying instead of 2 lakhs, it is showing 1,39,000 something. Same thing, you run it once again. It is giving 1,44,000. Same thing, I'll run it once again. It is giving 1,08,770. What is the reason? Last class I discussed that since the P is incremented and P requires 3 lines, if the first line, after the first line, if the context switching is happening, we are not getting the same result. Because if initial value was 5 and P++ will be done by the T1 thread and P++ will be done by the T2 threads, you are expecting that the last result should be 7, but it may be 6, it may be 7. As I told in the last class, how the context switching is happening, and because of that context switching, it will be, give you a different result. So what you need then we require a synchronization. So next topic it is how to make a synchronization. So जैसे बताया था, अंदर घुसने से पहले एक लॉक लगा दीजिए, बाहर आने से पहले एक लॉक लगा। सोचिए कि दिस इज योर टॉयलेट, दिस टॉयलेट इज यूज्ड बाय ऑल 5 members of your family or 10 members of the family. Since it is a common area, you cannot say that my toilet will be open. So what you do? You fix a door or a lock. The moment one enter into this toilet, he has to be put the lock. The moment he has to be come out, then open the lock, open this lock, so that next person will be enter. Because this is a common area used by more than one people, then there is a sharing. If there is a sharing, there is a requirement of synchronization. So this sharing concept you have studied in one topic in the prior to this. If you have remembered, that is a multi-processing operating system. The multi-processing operating system is what? What is the difference between multi-programming and multi-processing? Anybody? What is the difference between multi-programming and multi-processing? देखिए कैसे होगा, ऐसे पढ़ाई नहीं होता है. What is the difference between multi-programming and multi-processing? Yes, anybody? नहीं आता है? आता है कि नहीं आता है? What is multi-programming? At least tell me. Are you listening or not?
One job is played at the memory in the same time.
Very nice. Means more than one job will be executed. Then what is a multi-processing? I told that more than
one CPU is used.
very nice. More than one CPUs are present. When there is a more than one CPU, so you know, people, you should tell quickly. If there is a more than one CPUs are present, that is a CPU 1, there is a CPU 2, there is a CPU 3. I told that there is two kinds of operating system, two kinds of multiprocessing operating system. One is a shared memory multiprocessing operating system, where all these processors are using the same memory. Another one we have studied, that is a distributed memory operating system, where every CPU has their independent memory. Yes. So what is the problem? In this particular case, since everybody are using a single memory, there is a requirement of synchronization. Yes, the same thing is happening in this case. Since my P++ is going to be executed by more than one threads or the processes, I need a synchronization for this. What is the next topic? Okay, this is the idea. So today's class will start with the new topic, that is called as the most important with respect to your mark is concerned. That is called as scheduling algorithm. Mostly numericals, nothing else. Yes, I hope you will get interesting here. So what is a scheduler? Where the scheduler is used, I told. How many types of scheduler were present?
Long, short.
Very nice. Long, short, and a medium-term scheduler. Where the short-term scheduler is used?
In the CPU and ready queue.
Very nice. Why is the long-term scheduler is used?
Job schedule.
Secondary
Job scheduler.
ready.
Why it is called as a job scheduler? It will take a decision to enter the jobs to where?
Ready queue.
Ready queue. Where the medium-term scheduler is used?
That swap in, swap out.
Swapping, swap out. Very nice. Now this CPU scheduling algorithm, mostly we focus on the short-term scheduler. Yes. And what is the scheduling algorithm's most important job? We studied if it is my ready queue, ready state, and if it is my running state, then which process is going to be entered into the CPU, that decision has to be taken by a scheduler. And the scheduler is nothing but a program, and that program is using certain algorithm, and with the help of the algorithm, among n number of processes which are currently present in the queue, this ready queue, one of the processes will be selected and come here. That's why this scheduling algorithm basically say that which process is going to be selected for execution. Okay, so which process you have to select so that it will go for the execution. Okay, and this scheduling algorithm basically of two types. So one is called as the preemptive, and another one is called as non-preemptive. And what is the preemptive, non-preemptive? We'll go for this. So first we'll go for the non-preemptive scheduling algorithm. So what are this, before going to this non-preemptive scheduling algorithm, what is the criteria? What are the scheduling criteria? The scheduling criteria means what? When you design a scheduling algorithm, what are the things or what are the characteristics you have to look into? Okay, so that when one will design this algorithm, he has to be satisfy all the criteria. If it is satisfying all the criteria fully, then it is a better scheduling algorithm. So the basic scheduling criteria are, first one is called as the CPU utilization. Little theory, please write down, then utilization. The second criteria is called as the throughput. The third criteria is the turnaround time. Turnaround time. The fourth one is called as the response time. And fifth one is called as the waiting time. Yes. So what is a CPU utilization? Means all these 5 criteria has to be satisfied when you design any scheduling algorithm. Okay. So what is the CPU utilization? The CPU utilization basically says that how much percentage of time the CPU is busy. CPU is busy. Okay. Then throughput says that the number of processes, completed in a unit time. Yes, what does it mean? Your algorithm has to be designed in such a manner that the percentage of time the CPU is busy should be high. Means this should be a max.
100.
Similarly, what the throughput says that your algorithm is such a way that the more number of processes completed in a unit time. Means if you can calculate every per unit time how many processes are completed. Suppose you have designed a X scheduling algorithm, another have designed a Y scheduling algorithm. If I run this X scheduling algorithm inside my operating system, if the throughput says 10, in another scheduling algorithm, if I run it, the throughput says 7, means my 10 who is performing 10 throughput, that is better, because in that particular algorithm, more number of processes are completed per unit time. So that's why the throughput has to be also maximum. But most interesting thing are these 3 parts which you may not know. Okay, so what is a turnaround time, response time, and waiting time? I'll discuss with you your question. The turnaround time basically says the time interval between the job submission and job completion. First write it, I'll explain you one by one and explain your questions also. And what is the response time? The response time is basically the time interval between the job submission and the time at which the job gets the CPU for the first time. Gets the CPU for first time. Yes, the waiting time is basically the time duration for which the job is waiting in the ready queue. In the ready queue. Okay, so what does it mean? This. So first one I told how much percentage of time the CPU is busy. In our machine, once I've shown only 30% CPU utilization is done, or 20% CPU utilization is done. Means it is too less. My CPU is capable to use up to 100%, but I can only use up to 20%. It may happens that I don't have a lot of job. That's okay. If I have a lot of job, but still my CPU utilization is 20%, means most of the time the CPU is idle and other things may be executed, but the CPU is not executed most of the time. So which is not good. So we require the maximum CPU utilization. Similarly, in case of throughput, I told the more the number of processes completed, then my algorithm will be more better. So what is a turnaround, response, and waiting? I'll give you an example. By this, no need to remember this definition. Suppose I am working in the college. I will enter into my department at 7 o'clock. And after that, I sit in my room. I go to class, take class for 2-3 hours. Then at the 5 o'clock, I left the college. I completed my work and left the college. So what is this turnaround time? What is the response time? What is the waiting time with respect to this example? So I reach at college, my department at 7, leave at 5. So the total time I stay inside the college is 7 to 5, which is nothing but 10 hours. So here the turnaround time is saying job submission. So may submit I have submitted in my college at 7. I completed my work at evening 5. So the total hour is 10 hours, which is a turnaround time. Okay, got it? Then what is a response time? Suppose inside my department, there is only one classroom is present. And every teacher is going there, taking their class and come back to their chamber. So what I did, I entered into my department at 7. But what happens? I got a chance to take the class in that classroom at 10 o'clock. Means first time I got a chance. Then after I have taken many classes, but first time I got a chance to take the class at 10 o'clock. So what time I entered to the college? 7. What time first I get a chance to enter into the classroom where my job is to teach? That is at 10 o'clock. So the response time is 3 hours. Are you getting my point? Because 7 o'clock I enter, 10 o'clock I get a class. So this 3 hours is my response time. Yes. So now you understood what is a turnaround time. When I submitted, when I complete my work, that is the whole thing turnaround time. But the response time means I shout, I have entered into the college. Please give me a classroom. But the classroom I get it at a first time I got the classroom at 10 o'clock. Means my response, my department, head of the department is listening after 3 hours. So that is my response time. Okay. And what is a waiting time? Waiting time means suppose 10 to 11 I took class and again I took 1 to 2 and again I took 3 to 4. These are the classes I have taken. But I stayed up to what? 7 to 5. So if you can guess here, the 7 to 5 is total 10 hours I stayed there. But my job is actually done at 1 hour, 1 hour and 1 hour. So total 3 hours. Means 7 hours I have just waited in my chamber or someone else. Are you getting my point? So total turnaround time is 10 hours. I stayed there for 10 hours. But actually I worked there for 10 to 1, 1 to 2 and 3 to 4. That is 3 hours. So the 10 hours minus 3 hours, is almost 7 hours. So 7 hours I am waiting. And that definition here it is say that how much time it has stayed in the ready queue. Because what is this 10 to 1, 1 to 2, 3 to 4? This is executed by CPU, executed by CPU, executed by CPU. So the rest of the times I am either in the ready queue or somewhere else. But mostly they are saying that waiting time is how much time you are staying in the ready queue. That is basically your waiting time. When you submitted, that is the new state. When you terminated, that is the termination state. That is the total time is the turnaround time. And what is the response time? First time you submitted, after the submission, when first time you get the running state, that duration, submission time till first time you get enter into the running state, that is called as response time. Now you guess this turnaround time should be max or min, it will be better for an algorithm. The turnaround time should be more, then your algorithm is better, or less, it will be better. Anybody?
Less.
Less, it should be less, minimum. Then response time should be more, or response time is less, it will be better. Less.
Or less.
Yes, waiting time also you have to less. Then what is saying? These three has to be less and this two has to be more, then only my algorithm is better. Yes, ask now the question.
Sir, in the example you have given, sir, there the waiting time will be 7 because that first we are waiting 3 hours, then in from 11 to 1 there is 2 and then 1 and 1 respectively. So there is 7 hours waiting.
Yes, correct. 7 hours waiting. I have written 7 hours waiting. Correct. Perfect.
Okay.
Yes, 7 hours waiting. And turnaround time kitna hai? 10. And what is the response time here? Response time is 10. Anybody has a doubt in this? This is very, very necessary for the next topic. Immediately next topic. Is it clear for everybody? What is turnaround time, response time, and waiting time? Turnaround time bolta hai ki when I submitted, when I completed, during that duration. Response time is telling when I submitted, but when I first time get a chance to executed by the CPU. That is called as the response time. Waiting time is that basically the definition says that how much time you stayed in the ready queue. It means that how much time you stayed, how much time you actually executed. If you make a minus, the rest of the times you are in the ready queue, mostly. Okay, so that is the idea of these three things. Now we'll go for this. I have not discussed what is the preemptive and non-preemptive algorithm, but we'll start with one by one algorithm. The first simplest algorithm. Yes, ask. No problem.
Sir, in all the processes, these parameters are given that CPU utilization response time.
CPU
all the
utilization?
process.
No, not getting. 1 second, please.
Sir, in all the processes, the template of the structure is like this, that how much response time, waiting time, turnaround time.
No, that usually you have to calculate. Based on this calculation, you can say my algorithm is better. It is not necessary to calculate while you are running the programs. He is saying if n number of people have prepared their own scheduling algorithm, then which one you will select? Are you getting my point? Suppose 10 scientists have prepared their one algorithm. They say that hey, this operating system, please use my algorithm. Another will say, no, don't use his algorithm, my algorithm. You use it. Then how this owner of the operating system is going to select which algorithm will be the better? The criteria is this. That's why it is saying that scheduling criteria. Whichever satisfy more CPU utilization, more throughput, less turnaround time, less waiting time, less response time, the owner will be prefer that algorithm as compared to the others. Got it?
Sir, but that process should have a parameter that like waiting.
The process has a different. I have not told it what is the process parameter. I am coming to that. Okay. I am saying about only algorithm is like this. Now let's see what are those algorithms are currently available. So the first algorithm is called as the FCFS. That is first come first serve. Yes. So I'll give one example first, and it is basically a non-preemptive algorithm. What is a non-preemptive? Please remember, preemptive means forcibly taken away, forcefully taken away. Sorry. Forcefully taken away from CPU. Means somebody is executing, your algorithm so that in the middle also you can remove that process. Then that is called as a preemptive. If somebody is executing, unless until he himself told that I have to come out, you cannot remove him out. Like you can think about a toilet example, or somebody has entered, unless until he will say that I will come out, you cannot forcibly bring him out. If you are not forcibly bring him out, then it is called as a non-preemptive. If forcibly you can bring him out, then it is called as a preemptive. समझ में आ रहा है? Preemptive मतलब forcibly you can bring him out. But non-preemptive, since preemptive is forcibly bring him out, non-preemptive means you cannot forcibly bring him out. His choice. If one is entered into the toilet, his choice is that when he has to come out. You can also knock the door only, but he has to open the door and come out. Yes or no? So this is this kind of algorithm. So let's see what happens here. So I'll give you a small example of this. Assume that there are P1, P2, P3 are the three processes, and there is a CPU burst time is given to you. CPU burst means how much time this process is going to be executed by the CPU. Okay, CPU burst time, BURST. Let's take it as a 10, then it is a 5, and then it is 3. 8 minutes like this. Then we have to find out what is the turnaround time, what is the response time, and what is the waiting time if I run this algorithm using this FCFS. Means there are 3 CPUs trying to be execute, and they want, the P1 wants I will execute for 10 units of time by the CPU, he wants 5 units of time, and he wants 3 units of time. Then what should be my FCFS algorithm says, and based on this FCFS algorithm, what is the turnaround, response, and waiting time? Clearly, please understood. Huh? So what you did, you have to prepare a chart that is called as a Gantt chart, GANTT chart. So this Gantt chart is basically says that how much time from which time to which time which process is going to be executed. So let's take, they have appeared in this, means first P1 comes, then P2 comes, then P3 comes, or all P1, P2, P3 comes at the same time. Since it is FCFS, first come, first serve, you have to guess first P1 has come. So P1 started. How much time? Sir, 0 se shuru kiya, and he has to be executed for 10 units of time. So 0 to 10. Got it? Then it is completed. Then next is P2 is standing. So P2 will be executed. Then it is 10 to 5 is 15. Got it? If then P3, which is executed for 3 units, that is 18. So P1 executed from 0 to 10, P2 executed from 10 to 15, and P3 executed from this 15 to 18. So this is my Gantt chart. So from this Gantt chart, we can prepare what is a turnaround, response, and waiting time. So what is this turnaround time? So turnaround time says that the job submission and the job completion. And you know, in this scenario, since submission time is not given to you, means everybody has submitted at a 0. If it is submitted at a 0, then what is the completion on time of this? You start from this side. Huh? How to calculate a turnaround time easily, I am just showing you. You start calculating in this way, mostly. Yes? Then where the P1 ends? So P1 ends here at 10. When it has come? 0. So 10 minus 0 is 10. Again P2. So P2 when it is completed? Sir, P2 completed at 15. When it has come? 0. So 15 minus 0. So 10 minus 0 is 10. 15 minus 0 is 15. Similarly, P3 is 18 minus 0 is 18. So total, if you can calculate it, this will be 30 plus 43. total turnaround time of all three processes is become 43. Got it? Then what is the response time?
Yeah.
Please quickly tell me. What is the response time of a P1?
First
When
got
it has
the
come, when it has first time got the CPU. So when he got the CPU first time,
Zero.
0. When he has come, 0. So 0 minus 0. Got it?
10.
What is this one?
10.
He has start at 10. Very nice. So 10 minus 0 is become 10. And how to see the response time? The response time you have to check in this side. When the P3 has started at 15. So 15 minus 0 is become 15. So total comes 25. Then what is the waiting time? Just see at this point. At this point, how quickly you can calculate the waiting time? I told how much time they have stayed. Sir, A 10 units, A 15 units, A 18 units. सर 10 यूनिट से कितना घंटा काम किया था? सर 10 घंटा रहा था, 10 घंटा काम किया था. So 10 minus 10 becomes 0. Waiting time is 0. Yes or no? Because P1 reached at 0 and worked for 10 hours and completed at 10. So 10 hours he has stayed, 10 hours he has worked. So 10 minus 10 becomes 0. Got it? Can anybody, other student, please tell me what is the waiting time for this? No,
15 minus
think.
5.
That is
15
15. Yes. 15 is the whole time he has stayed and 5 times only काम किया है. So this is 5. So this is become 10. And this is stayed for 18 hours, but only 3 hours he has worked. So 18 minus 3 is become 15. So which is also coming. ठीक है ना? Calculate 18 minus 3 15. हाँ, ठीक. So 20. So if you can calculate it here, basically he has stayed for 28, 25 is the total waiting time, 25 is the total response time, and 43 is the total turnaround time. And if they will ask what is the average waiting time, average response time, average this, you just make it divided by 3, divided by 3. ये कर पाओगे कि नहीं? कुछ नहीं समझो, बस मैं बता रहा हूं कि ये अगर क्वेश्चन है इस टाइप का है. So what you have studied? We have to prepare a Gantt chart. We have to prepare this turnaround time, response time, waiting time by looking into this Gantt chart. That will be very easy. Once you prepare this Gantt chart, then by looking into this Gantt chart, I can quickly prepare. So better to prepare first turnaround time. Turnaround time से हम इस साइड से देखते हैं कब वो कंप्लीट हुआ है. So completion minus arrival. Response time में इस साइड से देखते हैं कब वो सबमिट हुआ है, कब वो स्टार्ट हुआ है, कब वो सबमिट हुआ है, कब वो स्टार्ट हुआ है. एंड वेटिंग टाइम अभी क्या कर रहा है? दिस वेटिंग टाइम इज बेसिकली टोटल टाइम ही हैज स्टेड फॉर दिस मोमेंट माइनस हाउ मच टाइम ही हैज टू वर्क. ही स्टेड 10, वर्क फॉर 10, सो 10 minus 10. He stayed for 15 hours, work only for 5 hours, so 15 minus 5. He stayed for 18 hours, work for 3 hours, so this is 15. So based on this, you are calculating. Okay. So one more example I'll give you. You have to calculate. Then I'll tell you what is the problem, what is the advantage, where it is. This kind of things has to be used. Okay. So let's see. One more example I'm giving. I have not told, but I'll ask you. That is P1, P2, P3, P4, and arrival time is 6, 0, 4, and 5. And response CPU burst time is this is becoming 4, then it is 2, then it is 2, and then it is 6. Yes, can you please prepare a Gantt chart for this with FCFS?
Sir, first P2 comes for 2.
आप कीजिए पेन एंड पेपर में, तुरंत कीजिए, तुरंत 1 मिनट लगेगा. आज से पूरा पेन एंड पेपर पकड़ोगे. हाँ, ज्यादा न्यूमेरिकल है, 3 क्लास तक, 2 क्लास तक एटलीस्ट. तुरंत कीजिए. This is arrival time, means this time the job was submitted. Okay. Then I'll calculate what is turnaround time, what is the response time, and what is the I'm not told, but still I'm asking because there this much intelligence you have. अगर 4 job आया है at this time and they want to be executed for this much unit by the CPU and you are following FCFS. So which job will be first execute? Tell me. Which job will get a chance to be executed? P2. Very nice. P2.
0 to 2.
From 0 to 2.
2.
So it goes to 0. It is completed. I always prefer like this. मतलब इसका काम हो गया.
4 is
Yes.
no empty.
हाँ. ये देखिए 2 o'clock को खत्म हुआ है. कब वो आया था? कब next process कब आ रहा है? 6 पे, 4 पे, 5 पे. Next process 4 पे आ रहा है. So up to 2 to 4 no work. Am I correct or not? Is it okay? Yes. Up to 2 to 4 nobody is executing. Means CPU is completely idle. Yes. Now tell me what is the next?
P3.
Who has come? P3. So P3 is coming. So P3. So P3 is executed for 2 units. So 4 से शुरू हुआ 6 तक. So ये भी complete हो गया.
Then P4.
At 6, who has arrived? During this 4 to 6, anybody has arrived? Yes sir.
Yes, sir.
जो arrive हुआ है उसको टिक कर दीजिए. इसका complete हो गया, क्रॉस कर दीजिए. So 5 and 6 has come. Sorry, P1 and P4 has come. Who has come first?
P4.
P4. So P4 will be first executed. How long it will be executed? 6. So 6 to 6 means 12 because 6 unit. Then it is also completed. And which process left? Only P1 left. How much unit? 4 unit. So P1 will be 4 unit. 12 is 6. Got it?
Sir, P4 starts with arrival with a 5.
No. Arrival with 5. Correct. Arrival with 5. But वो काम कब शुरू किया? P3 खत्म होने के बाद कि नहीं?
Yes, sir.
Yes. So P3 कब खत्म हुआ बोलिए? Because P3 has started at 4 and executed for 2 units. So 6 o'clock में खत्म हुआ कि नहीं?
Yes, sir.
Okay. So since he has completed 6 o'clock, next process will be start from the 6 only. Because we have only one CPU. Since you have one CPU, from 6 o'clock starts and it gets executed. Got it? By looking into this Gantt chart, can you prepare the turnaround time? बोलिए एक एक करके कैसे बोला था? नहीं प्लीज सुनिए कैसे बोला था turnaround time? सर कब सबमिट हुआ है कब कंप्लीट हुआ है? सबमिशन तो ये दिया गया है. कंप्लीशन किस साइड से देखेंगे? इस साइड से देखेंगे. बहुत इजी से देखिए. सो P1 देखिए P1 कब वो कहां पर टर्न है? सर P1 का टर्न सर यहाँ है 16 पे खत्म हो रहा है. सो तुरंत 16 माइनस 6. वेरी नाइस. यस इसको लिख लेंगे 10. फिर बोलिए P2 का यहां से देखोगे यहाँ से यहाँ से P2 यहाँ 2. सो 2 लिख दीजिए. सो कब आया था? 0 पे. सो 2 माइनस 0 2. देन अगेन P3 6. So 6 minus 4 become 2. Then P4 here. P4 का यहाँ 12. So 12 minus 5 is 7. Got it? Yes?
Yes, sir.
ठीक है ना? अभी बोलिए रेस्पॉन्स टाइम कैसे देखेंगे? इस साइड से देखेंगे. लेफ्ट साइड से देखेंगे. देखिए P1 का रेस्पॉन्स टाइम. P1 कहां से शुरू हुआ है? यहाँ नहीं यहाँ शुरू हुआ है सर 12 पे. लेकिन कब आया था? 6 बजे सर. So 12 minus 6. Are you getting this one? What is the response time? कब वो आया था? कब वो पहले शुरू हुआ है? So काम शुरू हुआ है उसका 12 बजे. But he has reached at the office at 6 o'clock. So 12 minus 6 is the response time. Then similarly tell me P2 का देख लीजिए. शुरू हुआ है 0 पे, आया था भी 0 पे. So response time 0. P3 का देखिए. P3 is 4. So 4 पे आया था भी 4 पे.
0.
So 4 minus 4 becomes 0. Then P4 6 आया था 5 पे.
1.
Somebody is asking now, sir 5 पे आया था आप 6 पे कर रहे हैं. Are you understood? This 1 unit becomes by response time because वो 5 बजे आया था 6 बजे उसका काम शुरू हुआ. So first 1 hour he didn't do anything. Okay. Then what is the waiting time quickly? अभी के लिए टर्न अराउंड. बाद में थोड़ा वेटिंग टाइम का रूल चेंज करेंगे. अभी के लिए इतना ही चलेगा. सो 10 o'clock 10 बजे वो आया था एंड सो 10 एंड कितना घंटा काम किया है? 4 घंटा. सो 10 minus 4 becomes 6. ये कितना टाइम रुका था यहाँ पर? 2. काम किया है कितना? 2 घंटा का. So 2 minus 2 becomes 0. Okay. Similarly, tell me what is the waiting time of this? He has also stayed for 2 hours, worked for 2 hours. So this is also 0. And he has stayed for 7 hours, worked for 6 hours, then it is 1. So this is become 7, this is become 7, and this is become our 7 to 9 to 11 is 21. Got it? Is it okay? Understood?
सर तो रिस्पॉन्स टाइम और वेटिंग टाइम सेम होगा?
सेम अभी आ रहा है, थोड़ी देर बाद चेंज होगा. ओके, अभी के लिए सुन लीजिए सेम है. क्यों सेम हो रहा है बोलिए? क्यों है इसका सेम है? कोई बोल पाओगे?
सर बिकॉज़ प्रोसेस स्विच नहीं हो रहा बीच में.
हाँ, because of non-preemptive one. Because once you join now, you will be complete. Yes or no? So waiting time इसका कितना होगा? Joining तक जितना waiting time था उतना ही. उसके बाद तो और बढ़ेगा नहीं ना? Because once he has started this work, he will complete his work. In the middle, he will not come out. So that's why इसका response time जितना है, waiting time जितना है. Very nice question you have asked. Are you getting everybody? Because as per the non-preemptive scheduling, he is saying once you enter into the CPU, you will complete. You will not come out. Somebody will not tell you that you have to come out in the middle. So if it is like this, then up to enter तक, जैसे देखिए P4 का 6 बजे entry, sorry, 5 o'clock he has entered, but 6 o'clock he has started. So response time कितना हुआ? 1 unit. But up to 6 o'clock waiting time भी कितना था? 1 unit के नहीं. Are you getting my point? When P4 started his work at 6 o'clock, but he has joined at office, joined office at 5 o'clock, then the response time 1 hour हुआ, because 5 बजे आया था, 6 बजे काम शुरू किया. So 1 hour is the response time. That 1 hour is also waiting time up to 6 o'clock or not? Because उस टाइम तो कुछ नहीं कर रहा था, मतलब वेट कर रहा था 1 hour. But after he has entered into this, is there any possibility of a further waiting? No. Why? Because as per the non-preemptive scheduling, once a process start executing, there is no way to bring him out. Since there is no way to bring him out, then what is the scenario? The scenario is simply, you can say, this response time is equal to the wait. Okay, that's the case. So this is basically a fast come fast. And what is the advantages and where it is used? This kind of a fast come fast serve is mostly used in case of a batch batch processing operating system. Means what? That long jobs are coming, very huge size jobs are coming, and they don't requires a lot of time. So that's why they don't look into it anything. They just put it the way they are coming. Yes, this is very simplest one. But the same jobs can be again reduced further by a certain way. And what is the problem? One basic problem comes. Suppose look into the previous example. He has a 10, he has a 5, and he has a 3. Is the CPU execution time. आप अगर देखोगे, all the processes if it come at 0 o'clock, then this last process has to be waited for 15 units of time. Correct कि नहीं? क्योंकि ये दोनों खत्म होने के बाद ये शुरू हो रहा है. And this process is waiting for 10 units of time. Because unless until first process complete, he cannot start it. And you can observe one thing here. If initial processes are very big, then later processes has to wait for a very long time. जैसे बोलते हैं ना हम कभी-कभी क्यू में खड़े होते हैं, जब भी क्यू में खड़े होते हैं कभी कोई बोल देते हैं ये मेरा 1 मिनट का काम है मुझे छोड़ दीजिए. वो बोलते हैं हाँ मेरा 10 घंटा का काम है आपका 1 मिनट है ना पहले काम कर दीजिए. Then in that case what? The person who needs only 1 unit of time, it does not has to be wait for long. But the person who requires a long time, if he first executed, the rest of the people has to wait for a lot. Means what approach you are saying? If initial processes requires a long time to be executed, then if you are following FCFS, then obviously your waiting time will be gradually increasing because latter processes has to wait for a long time. जैसे बोलते ना मुझे 10 टिकट ट्रेन टिकट निकालना है, कोई बोलता है कि मुझे एक ही आदमी का एक ही टिकट चाहिए, कभी कभी बोलते हैं हाँ आप पहले ले जाओ हम लोग बाद में ले जाएं क्योंकि हमारा पूरा एक ग्रुप हम लोग जा रहे हैं. In the same manner, if this particular scenario can be solved in a different way, so that my waiting time gets reduced, because here the waiting time is increasing because the high jobs are executing first if they come first. But what to do if the low CPU burst time jobs will be executed first? Then definitely my waiting time gets reduced. And what you need? You need that. Why don't you execute the shortest job first? So no, those processes requires very less unit of time. Why don't you execute them first? If you execute them first, then your waiting time gets reduced. Am I correct or not? Are you getting this point? Yes or no? Yes. Okay. So that,
Sir, we can put the two processes in different queues.
hey, I have only one queue. No, we are maintaining only one queue, ready queue. Why we are maintaining a ready queue? Because I have only one CPU. We are here. You are considering a uniprocessor system. Means there is only one processor and they are executing. If there is one processor, currently we are only studying about a single queue. If it is a single queue, definitely what to do? Better to bring these processes to the beginning rather than this process. And that algorithm is basically called as shortest job first.
Sir,
बोलिए.
another problem is that, sir, we don't know that CPU burst time.
वो थोड़ा सा रुक जाइए, मत बोलिए. वो क्वेश्चन, ठीक है ना? That is SJF. So the SJF basically says that the jobs which are lesser execution time, they have to execute first. So what is your job? That is a P1, P2, P3, 10, 5, 3. So P1, P2, P3, and it is CPU burst time is 10, 5, 3. So in this case, if it is coming, then how the Gantt chart will be prepared? Here it will prepare that whichever has the less execution time, that will be executed first. So we will execute first P3. How much? 0 to 3. Next, once it is completed, next lesser time, that is 5. So that is P2. So P2 will be executed. That is from 3 to this. 3 to कितना होगा? 5 unit मतलब 8. सही कर रहा हूँ? Then P1. So it is also over. Then P1. So the P1 will be executed for how much time? 10 units. So this is 8. So here also 18 completed. Here also 18 completed. But can you quickly tell me what is the turnaround time, response time, waiting time, TT, that is response time, RT, WT, TT for this, कब complete हुआ?
18.
P1, 18, कब आया था? 0, so 18. इसका complete हुआ बोलिए? P2 complete हुआ? 8 बजे, आया था 0 बजे, 8. P3 complete हुआ 3 बजे, आया था 0 बजे, so 3. Response time quick, इसका response time, P1 का response time इस साइड से देखते हैं, कब शुरू हुआ? 8, आया था 0, so 8. That is 8 minus 0, is 8. Similarly, P2 का response time 3 बजे आया था, 3 बजे शुरू हुआ, आया था 0 बजे, so 3 minus 0. Then P3 का response time आया था 0 बजे, शुरू हुआ भी 0 बजे, so 0. So 8, 3, 11. So what is the waiting time? Total turnaround time minus execution time. So 18 minus 10 is 8. 8 minus 5 is 3. 3 minus 3 becomes 0. This is 11. Now you see, total is 11. So average waiting time is 11 by 3 is something. So here it is 11. Here it is 18 plus 3. Calculate करोगे तो कितना आया? 11, 8, 29 ना? 29. Yes, 29. And this is also there. Now if you can compare with this along with this one, here it is a 25 waiting time total. But here it is 11, 2 less or not. Then what you understood? If you apply this shortest job first, then it will perform better because my short jobs will be executed first. So the longer job has to be wait for a less period of time. If the longer job will be executed first, then the shorter job which is present later, they have to wait for a less time. Okay, just last. Can the same thing you apply with this shortest the first? P1, P2, P3, P4, 60, P1, P2, please apply it quickly. P1, P2, P3, P4. This is 6045 4226. 6045 4226. So see, this is arrival time and CPU burst time. Can you apply the SJF here? SJF and do the turnaround time, do the response time, do the waiting time. Quick. Shortest जब फर्स्ट हाँ थोड़ा सा चेंज होगा इसमें और उसमें हिसाब से then we'll start.
Sir, yeah, P2 0 to 2.
P2, if it is wrong, you tell me, others. He is saying P2 पहले शुरू हुआ 0 पे आया था, so 2 unit, so 0 to 2. Very nice, correct.
Empty.
Then
Till 4.
2 बजे और कोई नहीं आए हैं, 4 बजे आए हैं, so this is empty, so 4 बज गया.
4 to
Got 4 o'clock, he has arrived, P3, correct. कितना तक? 6 तक.
P1.
6 तक, ये भी खत्म हो गया. Up to in at 6 o'clock, who has arrived? Sir, AB arrived हुआ है, AB arrived हुआ है. Got my point? So out of these two, which one will be first execute?
P1.
इसका कम टाइम है. So he has
Till 10.
this is P1. Then 6 to 4 is 10, and this is 6. So 6 to P4 is becoming 6. Okay, so this one. Yes. So before you come to the next, I think you can prepare the turnaround, response, and waiting, because this chart and this chart are exactly similar. P2 02, this is 24, P3 6, P4 62. P4 we have taken here little change. Here it is P1 come first, then P4. Here it was P4 and P1, because as per the FCFS, he come first and he comes later. That's why P4 first executed, then P1. But in this case, after 6 o'clock, once this P3 gets completed, 2 jobs has arrived. P1 also arrived, P4 also arrived. Then as per SJF, whichever has the less execution time, that will be executed first. So since he has a 4 units, he has a 6 unit, he will execute first. Okay. So one example, you have to do it in the home before you come. That is P1, P2, P3, P4. Then it is arrival time. Arrival time is 5, 6, 0, and 7. And the CPU burst time is 3, 5, 3, 5. Let's take 6 and 2. Okay. So you have to do.
Sir, can SJF happen with preemption?
Next time. इसके बाद तुरंत.
Sir, वो क्या है? वो arrival time.
Shortest remaining time first schedule. Exactly what you are asking. Okay. And somebody's answer I have not told. Somebody told very nice question. Sir, as per the FCFS, it's okay, because the person who come first, he will execute first. But in case of SJ, he is saying the person who requires less execution time, he will execute first. Now the question, his question was, how can you know prior to the execution that how much time he needs?
Sir, by the size of the program.
You cannot say. Based on the size of the program, you cannot say. Because you know, the size of the program may be 10 lines, but inside this 10 lines, suppose there is a 3 inner loop. And another program is 100 lines, but there is not a single loop is present. Then by size can you determine? Not.
Sir, I guess it is by the previous record.
That's why they are saying this SJ is not a non-realistic one. Yes, because we don't know how it is the time of the CPU, how much time it is required. Then you can ask, sir, ये भी तो आप कर रहे थे अभी ये भी तो किए थे. But here, if you can look into it, here the way it is comes, I am executing, and during the execution, he knows it is 4 hours or 2 hours or 2 hours. But here, based on the execution time, I decided that who will execute, which is not possible. Okay, next class पढ़ेंगे. फिर क्यों सीखे हैं फिर? इसका जरूरत फिर क्या है? ये तो रियलिस्टिक नहीं है. क्या करोगे? पेन एंड पेपर में करने के लिए सीख रहे हैं. नेक्स्ट क्लास पढ़ेंगे. ठीक है ना? थोड़ा आपको प्रीवियस थिंग्स आपको पढ़ना है, हाँ? But today you will get the assignment. I will not today's delay. And your assignment today you have to prepare in XB6. Just सीख लीजिए. XB6 में आपको एक डेट कमांड बनाना है. Okay, you have to prepare a date command, and also you have to I thought about you have to prepare a system call called as a wait all. हम wait सीखे थे. wait क्या करना था? एक ही चाइल्ड के लिए वेट कर रहा था. But to make all the child to be wait, I told that you write in a while loop. This wait.
Null.
Why don't you prepare a system called wait all, which will wait for all the childs?
सर वो डेट क्या है?
हैं? डेट है ना आपका कैलेंडर जो है ना, कैलेंडर ऐसे बनाते हैं ना हम. डेट 2000 सॉरी
कैलेंडर ना.
हाँ सॉरी कल ना. क्या था कमांड? कल ना.
यस.
यस, आपको इस टाइप का ना. ठीक है, इस टाइप भी नहीं बना पाओगे. एटलीस्ट आप बना पाओगे अगर मैं देता हूं दिस कल जान देता है क्या? नहीं, जनवरी शायद, सॉरी कल अक्टूबर.
शायद वो करना होगा साल और फिर हाइफन देना शायद.
नो नो प्रॉब्लम, ये देख लेते हैं. अक्टूबर ऐसे देता है. नहीं तो मैं मैनुअल देखूंगा. मैं बस ऐसे टाइप कर रहा हूँ, शायद दे देगा. हाँ? नहीं देता है तो कल क्या लिखेंगे? मैन कल देता है. ओनली कल.
सर फर्स्ट वी हैव टू राइट दैट ईयर ना.
हाँ, दिस इज गिविंग दिस मंथ. आई वांट स्पेसिफिक वन. सो कल
वी हैव टू स्पेसिफाई द ईयर आई गेस.
हाँ, इट इज गिविंग like this. Kal 5 this. 5 means 5th month. Okay, May. That is May, month of May. And 2000. So 2000 ka May month. So like this, you have to prepare a command so that आप सीख पाओगे सिस्टम कॉल कैसे बनाते हैं. एंड कल मैं कुछ हिंट भी दूंगा. Yes, and I will also share in the Moodle that how to make a simple system call. Then you have to look into it how to prepare these two things. And you prepare a group. Next class, by this time, you write in a Word file that what is your, or Excel file, what is the roll number of your group. Okay, these are the two. One more I have thought, but currently I am not telling. Once you finish this, I'll tell you that. This, you have to prepare a wait all system call, which will wait for all the childs, and you prepare a command called as a date. Inside the expression.
सर ये कोई सी प्रोग्राम होगा या
ये
फिर
पूरा
वो
सी
बैक
दोनों सी
प्रोग्राम?
पूरा completely. Because your XP6, I have shown you the whole thing as written in C.
ओके सर.
Okay, that's all. Ending, huh?